Hi everyone. Let's discuss another Leetcode problem. And today's problem is problem 208, implement Trie data structure. If you haven't watched my lecture on Trie data structure, I would suggest to go back and watch that. That will give you a very nice theoretical foundation on Trie. But if you don't watch it, it still is fine. You can just learn about this data structure through practicing, throughout practicing this problem. So here's the definition of a trie. A trie or prefix tree, this is also known as prefix tree, is a tree data structure. It's a tree data structure used to efficiently store and retrieve keys in a data set of strings. So this data structure is used to store and retrieve keys or strings. Okay, and the word trie actually comes from these retrieve. There are various applications of these data structures, such as autocomplete and spell checker. If you have watched my lecture, I already have talked about both of these features in details. Okay, so what we have to do in this problem is we have to implement a trie class where it will have a constructor trie, which will initialize the trie object. Okay, and then there is we have to implement insert a method which inserts a string, any string word into the trie. Then we can do a search with parameter as a string. It will return true if that string is already in the trie, or return false if that string is not in the trie. Or we can do prefix search. So the method that we have to implement is starts with, and as parameter we have to put a string, a prefix string. It will return true if that prefix is previously inserted into the trie, or false otherwise. Okay, so let's take a look at example. So if we take a look at this example, say a new trie, right? So we have to create a trie node actually to create the trie. You know, tries is some kind of tree. When we are building tree, we had this tree node. So we have to have this trie node. So what trie node has? Trie node has a value, and then it will have an link to the children. So in the constraint here, you see this, for this particular problem, the word and the prefix, these strings consists of only of lowercase English letters. So we can see that this one, actually the link to the children actually looks like this. So this is this, okay? So this looks like this. And since there are like only 26 small cap letters, we can keep an array of 26 where the first index 0 will represent A and index 25 will represent Z. Okay, so this is a trie node. And finally, there is a flag saying if this is an end of the word or not. Okay, so this is a trie node. Okay, so we know that any trie actually has a root. It has a root, and from there it actually keeps on building the tree. So let's take a look at that one. How can we actually build a trie? So initially, when we actually create a new trie, what we have to do is we have to create a root. Okay, so we have to create a root node, and the root node will have children looking like this. And then we say we do insert apple. So if I insert apple, any word, okay, so any word, if we want to insert that word, we have to start character by character. So we have to go to A and go to the root. We go to the root and see if already there is a trie node for A. And initially you see, so this is what we are checking, right? This is inside the root node. and we see initially all of them are empty. So there is nothing. So what we have to do is we have to create another try node for A. Okay, and this one will also have a, a list of links to the children, and is word flag is false. At the beginning it will be false, and then what we have to do is from here we have to link it. Sorry, so we have to create a link to this. Okay, so that means we have created a node for Apple. Next, okay, so the next thing is we have to look for P. Now this time I will look in this one, right? So assume that this one actually looks the same, right? So look for P if P has anything. So you see here, all of these are empty. All of these are empty. So what we have to do is we have to create another try node for P. It will have its own list of children. Yeah, this is also false. Like this is not a word. This is not the end of the word. And what we have to do is we have to, so basically doing this is like say P is here. Okay, so I'm creating a link here. Okay, and so eventually if I just draw the whole thing, it will look like this. So by inserting Apple, we'll have this root node, and then we'll have A, P, right? P, L, E. Okay, and only here the is word becomes true. Only here it's true. Okay, next we have to search for Apple. So the search, how the search will work is it will first go to the root and look if there is a node for A. Yes. If there is a node for P, yes. If there is a node for P, yes. And node for L, yes. And node for E, yes. Now, once we reach the end of the string, at the same time, we have to see, check if this is the end of the string. Okay, if both of these are true, then we return true, which is true here. Okay, next, let's look for search app. So we'll see if the word app is in the try. So we'll start from the root. A is there, P is there, P is there. But so we got app, but the problem here is like the end of the word was false here because we didn't insert the word app, right? So basically search and search with, sorry. Okay, so you see that this is false, right? So that means we have inserted Apple, and because of that, there is a true flag set at E, but we haven't inserted app. So the is word is false at this node, so we return false. Okay, and next we will look for starts with, which is a prefix search. So we will look for search for the prefix app. Now you see, we first will check A from the root, then P. Yes, that's true. And since now we are looking for prefix, we are not actually looking for a word, just a prefix. So this is enough. Like we got all the characters, right? We got all the characters. So prefix search is successful. So it starts with this will be returned true. Next, what we do is we insert app. So we go to the root. You see already we have a node for A, so we don't need to create one. And then already we have a node for P, we don't have to create one. And we have a node for P, so we don't have to create one. And we have reached the final character. So what we have to do is we have to set this is word equals to true. Okay, so when we insert in the final character, we make it is word is true. Next, we search again, and this time it will return true. Now look at this one. Initially, when we were actually looking for app, this returned false because till then, although we had inserted Apple, we didn't insert app. But after we inserted app, now the same search is successful. Okay, so hopefully this thing is now clear to you. we will go to the code and it will be more clear to you. Okay, so let's try to code this thing. So you know that every trie needs a root. So first we have to define another class for trie node. Inside a trie node, every trie node will have a, say, character value for this problem. So it will have a character, and then it will have a list of children. So for that, we will have an array of trie nodes for children. And since this particular problem only has, okay, so let's keep this. So this is a children, and then there is a flag to denote if this node, if a particular node is an end of word or not. Okay. Then let's have a constructor, say given a character value. We can create a trie node where the value of the character will be set as the value of the node, and then we'll have initiate an array of size 26, because in this problem there are like only small case letters. So index 0 is going to denote A, and index 25 is going to denote Z. And finally, is word is false. Okay, let's have another constructor, because for suppose a node can have no values, suppose a root node, right? So root node comes without any value. So it's not necessary for a node to have values, but still it will have a list of children, and isword will assign it as false. Or you can just leave it. That's also fine. Okay, so we have our trie node. So every trie will have one root. And once we initiate the trie, this function, right? So new trie. Once we do a new trie, we should create a trie node. Okay. Then for the insert, what we have to do is we have to start from the node, from the root, sorry. So we say trie node equals to root. We have to start from the root, and then we'll read one character at a time. We'll convert this to character array, and each read one character at a time. And we'll check if the current node's children at that character's particular index. So how do we get that index? We get the value and subtract the ASCII value of small cap A, then we'll get the index. If that is null, then we will create a new trie node. That means no trie node has been created for this character C, right? Okay. Otherwise, else, what does else mean? Else means that a node is already there for this character C. So what we have to do is we have to next check, we have to change our node to the next node, right? Because next time for the second character, I am going to check that node. And that's it. I think that's it. Okay, finally, we have to do something. So once we are done with all the characters, then our node is pointing to somewhere. That's for the last character, right? Our node is pointing to the last character. So what we have to do is we have to set the flag isword to true for that particular character. That is the last character. Okay, so for the next two things are search and search with. So this is for prefix search. and this is for word or string search. They should be the same, but the difference is for a string search or word search, we have to make sure that once we reach the final character, each word flag has to be set to true. Okay, but for a prefix search, that's not necessary. Like, we don't care about if the last character is the end of the word or not. If we can reach till the last node, then we are fine. Okay. So let's copy some of these. So again, we have to start from the root node, obviously. Okay, and then we have to read each of the characters and then check if there is already a node for that character. If that is null, that means there is, so if for a specific character there is no trie node found, that means the word is not inserted into the trie, right? So if this is the case, then we say null. Otherwise, we just change to the next one. So that means, okay, so two cases. One is, suppose I'm looking for a character. There is no node for that character. There is no trie node. That means search fails. Otherwise, else means we have found a character for this. So we are going to the next character. So what we have to do is we have to go to the next node, and then we look for the next character in the next node. Finally, if we have reached here, that means all the characters have been found. So this was never executed. That means all the characters were found. Now what we have to do is return node dot isWord equals to true. Okay. So if this is the case, then the search, we say that the search is successful. For the prefix search, we'll do the similar kind of thing. Okay, and here I don't have to check if this is the end of the word. If we have reached this point, that means we have found all the characters in the prefix inside the trie, right? Okay, so let's run this. Let's submit. And you see this got accepted, and it was also pretty fast. So we'll come back with another problem next time. Thank you.